So let's go ahead and get started for today. So the main thing that I wanted to cover is, the status of the status of Peggy Testnet 1. Um, and my goal with Peggy Testnet 1 was to lose control of the bridge. Um, and my hope was that I would not succeed in that goal, but I expected that I would, especially for a first testnet. And that is the end result of the testnet right now, is that the bridge is currently inactive because not enough people are running their orchestrators, so the next measure can't pass. Now I knew what I was doing when I did this. I kept enough. So how should I put it? Okay, so let's start from the beginning with a summary of the testnet. First things first, we got the testnet online, and we immediately ran into some bugs around people joining the validator set at unexpected times. So there was a window between when the chain was actually started and when the contract was deployed, where if somebody were to join the validator set in that window, which could be a couple of minutes to several hours, depending on the exact timing of the testnet launch. The bridge would be deployed with the wrong validator set. Well, no, I should put it this way. The orchestrator would not know how to update the validator set on the bridge, because in the absence of a previous known set, it would use the current set, and the current set wasn't right because that was not the set that the bridge was deployed with. So that's what happened. That's a pretty easy fix. That's literally just you're putting the wrong input parameters into the contract. Then we dealt with some issues around ordering, where someone didn't quite sort things correctly, and they're the ones who submitted the validator set update to the bridge, and that halted updates for quite some time until I sat down and really solved this problem in earnest. So we got that done. Uh, and then there were a few more updates around making sure that making sure that the orchestrator didn't crash or generally have problems. And finally, I went and I handed over validating power, which up until that time I had kept the majority myself, specifically so that my validator could always pass measures on the bridge and we didn't lose control of the bridge too early in the test. Um, but what I found is that not enough people not enough people were running their orchestrators. So we didn't have enough signatures once I distributed validating power to continue to move measures forward on the bridge. Now, why is pretty obvious, because what I've just described leading up to this is like 8 different updates to the orchestrator. From that perspective, it's not terribly surprising that not everybody had kept theirs running. I was sort of hoping that we could get everything back up before the end, sort of before today, but that doesn't appear to be forthcoming, and frankly, I'm not terribly surprised. It was a stretch goal, anyways. Um, as far as like meaningful feedback for Peggy, we've gotten a lot out of this testnet. We've fixed several bugs that you find when people, are entering and exiting the validator set in unexpected ways. We have tests for this sort of stuff, but the tests don't cover every case, and there's always an element of chaos that a real testnet brings that's very valuable to find problems. So that's been a good contribution to the whole system. Um, Also, this exact sort of issue where people are not running their orchestrators and not submitting signatures to move stuff across the bridge is what we're covering in our new slashing update. So in a currently open pull request, we have slashing mostly done. Fingers crossed. Thank you, Jack. Um, and on the Peggy repo. And what this will do is that it will slash people for downtime if they do not have their, if they don't keep their orchestrator running and submitting Oracle events from Ethereum and submitting signatures for things that need to go from, well, actually, Trouble. The battery on this thing is starting to go out. Anyways, so back on subject. There is so I'm going to take a detour here and describe two things that we slash for, which involve the two different paths of Peggy. And so Peggy has paths from Ethereum to Cosmos, and then paths from Cosmos to Ethereum. So the Cosmos to Ethereum path needs what we call an ETH signer, and that is that orchestrators sign over events that the Cosmos module produces. For example, the Cosmos module will say, okay, we need to produce a new validator set update because the validator set has changed, and it produces a new validator set update. And the orchestrator has some code that's checking an endpoint on the validator and says, oh, look, there's something new for me to sign. It signs it and submits it back to the chain. And this is just an easy way of dealing with Ethereum signing because you can't bring a key into the consent. It's all very technical, but on a simple level, it's just signing stuff with Ethereum and submitting it back to the chain. And then eventually a relayer collects all these signatures and goes and does stuff on Ethereum. And one of the new slashing conditions is that you can be slashed for downtime if your ETH signer isn't running and, sitting there and signing the things that need to be signed. Because if you as a validator don't do that, the bridge halts and it's very bad. Not a happy time. The other flow, the Ethereum to Cosmos flow, is all about Oracle events, which work in a pretty similar way. Your orchestrator binary also contains an oracle, which observes the Ethereum blockchain, and as necessary, sends transactions on the Cosmos blockchain saying, I observed such and such event, such and such thing happened. And when enough validators have sent a transaction and said, I observed such and such event, tokens get minted, or various other things can happen. So those are the two things that the validators need to be running, and they will be slashed if they are not running. And they'll be slashed at the normal downtime rate by default, although obviously it's a configurable parameter and people can pick whatever they like. So yeah, this is exactly the sort of thing that would have saved the bridge from being stuck. Is that if people had to keep their orchestrators online, or they would be slashed and jailed, then we probably wouldn't end up with a validator set that did not have enough ETH signers online to pass events on the bridge. So long story short, I think we got most of the testing and most of the value we could out of Testnet 1. We made a lot of improvements, and I'm looking forward to Testnet 2 with slashing in the pretty near future. I'm not going to promise an exact date now because the code still isn't finished, and everybody knows how bad of an idea it is to make promises about timelines, promises about when code is going to be done. But yeah. So in Testnet 2, I am hoping to replay this same experiment and do absolutely everything I can to make the Peggy module and the chain lose control of the bridge, so that when we finally get into production, we have hopefully taken care of all of these cases and really ran this thing through the ringer as far as potential failure cases. Let's see, I think that covers everything I can think of off the top of my head. Are there any questions?
Justin, do you want to talk about what's coming up with other testnets and the demo day, incentivized testnets coming after that?
Yes, that's probably the best stuff to talk about next. Thanks, Deborah. So yeah, we have Peggy Testnet 2, which I am hoping for towards the middle of this month. Although, once again, we'll see. Not committing to a date yet. So Peggy Testnet 2 is going to focus around slashing. It's going to focus around more advanced testing of the bridge, more sort of bulk testing. I've been working on this cool little thing that will make a few thousand batches and send a few thousand transactions, and generally really try and ruin everyone's day. So that will be good to test with. And also it'll be a lot easier to get started. We have the instructions all like written out and refined. And frankly, we ended testnet 1 with 18 validators. We started it with only 10, which means that nearly half of our online validators came in after the original call following the instructions. So I think that's pretty great. We have a lot of community interest, and we don't necessarily need to lock everybody into a Zoom call to get things started now that we've refined it some. Um, and yeah, after testnet 2, barring anything really unexpected, we're going to move on to an incentivized testnet, probably early to mid February. Do you think that's reasonable, Deborah, or do you want to go late February? Obviously, not promising dates yet, just sort of planning.
Yeah, I mean, obviously, I think it'll kind of depend on where we're at after testnet 2. But yeah, I think, we'd like to, get in an audit and the incentivized testnet somewhere in the February area, which I think is going to be pretty fun. Do you want to share with them a little bit about how that incentivized testnet is going to kind of be structured? I also
Yeah.
put in the into the chat the block explorer too, which appreciate the community member that made that. That was Vint.
I have
Do
it
you
in my
know?
tweet, but I forget the name of the team exactly. I do think you're right on the name of the person, though. But there's uh, they're part of a team that sets up lots of different block explorers, which is really great. So it's probably best to attribute to the company. But anyways, for the incentivized testnet, essentially how it's going to work is that testnet tokens will be redeemable at the end of the testnet for a given amount, for a given percentage of the prize pool. Um, so, okay, yeah, so I'm sort of getting ahead of myself here. There's two categories that you want to reward people for in an incentivized testnet. You want to make sure that a potential attacker is rewarded, and you also want to make sure that the participants, if they successfully keep the bridge safe for the duration of the test, um, can be rewarded out of the prize pool too. So essentially, no matter what, by the end of the testnet, the prize pool is given to someone. It's either given to an attacker who has won by defeating the system, or it's given to or it is given to the validators that won by managing to keep the system from being compromised. So the validators will be able to redeem their staking tokens at the end for actual money in the bridge. Exactly how we're going to facilitate that, as far as modifications to the bridge and other things to sort of try and keep the game going for the duration of the testnet, have yet to be decided and need some design work, frankly. But that's roughly the shape of the plan. Is that we have um, is that at the end of the testnet, somebody gets to claim the reward, and if the attacker succeeds, they may be in possession of all of the tokens with which to claim the reward. A really preliminary thought on how we're going to do that is probably deploy an ERC20 on mainnet, and then once we call in on ETH mainnet, and then once we call some flag, we have a contract that stores all the DAI for the reward that will then redeem these that will at the end of the testnet be able to redeem these ERC20 tokens for DAI. Um,
Should be
so
fun.
yeah, and there's some stuff where you match the total balance, where you match the reward price to the total balance of ERC20s issued, etc., etc., etc. Yeah, so that's roughly the plan with the incentivized testnet, and yes, it's very exciting because once that's done, we'll be sort of ready to bring Peggy into production, which is a really big deal, and also it's going to be the most efficient bridge between Ethereum and anywhere else, actually, particularly because for cross-chain bridges, deposits to the bridge are always cheap and withdrawals are always expensive. Um, because and by that I mean deposits on the Ethereum side. So if you're sending money from Ethereum to some other chain, that's always going to be cheaper than it is the other way around. Because on the other chain, you can make design concessions to make it faster and easier. But on Ethereum, you only have the Ethereum execution environment and some very expensive signature verification. Um, so Althea is designed for Peggy by using large batches for transactions, produces by far the lowest costs. And in fact, it is feasible to use Peggy, and it will be only an additional 5 or 10% on top of your base ERC20 transfer. Even like right now, in the last couple of days, when gas prices have been a horrifying 400 GWay, so if you can afford to use Ethereum, you can afford to use Peggy, which is a lot more than can be said of many other bridges where you're looking at a single send from. So for other bridges in production, you're looking at a single send from the other chain to Ethereum costing you $10, $15 right now. On top of the actual ERC20 cost, which is like $1 or $2. With Peggy, you would be looking at a cost somewhere around $1.75, $1.25 to get your funds out of Cosmos and back onto Ethereum.
Ta-da! Everyone's quiet this morning. I know it's early on the West Coast.
Yeah. It's early, so
Super early.
yeah. Well, it's always the scheduling paradox. If we do it around 11 or noon West Coast time, nobody can show up. Um, People don't prefer early times, but they show up for early times. So,
Yes. Hey, I got a question.
sure.
Um, Arm Peggy, no
Yes.
longer pulling down. What's up?
Let me double check that. I might have accidentally deleted it again. Oh no, I
Sweet.
definitely accidentally deleted it. I can re-upload it in just a moment. Um,
Sure. No rush.
so
Just
there's
asking.
no updates to the Peggy binary itself. You only need ARM Orchestrator if you're trying to update your validator.
Great. Mine is running, so no problems there.
Cool. Yeah. I will fix ARM Peggy immediately after this call.
Yeah, it's up to you. Just pointing it out.
I've got a question for you. So
Mhm.
once the Peggy bridge is up and running, like the average path for a customer to get funds into their router, will that still be going through something like Wire through Ethereum onto the Cosmos blockchain?
Yes. So this is specifically for the Althea blockchain, and so I want to make that distinction for Cosmos community members who may be working with other blockchains. But the reason Althea is making Peggy is so that we can help onboard DAI to our customers' routers on the Althea chain, which we can make sure is up and reliable. Because if Ethereum has some problems, or like now it costs like $20 to do anything, the Althea kit chain can just chug along and keep having, transactions that cost that cost a quarter of a cent each or something like that. And everything can be good. Now, yes, for the time being, our planned deposit path is still to go through, Wire, then Ethereum, then Peggy, then the Althea chain, in much the same way that we're doing Wire, then Ethereum, then the XDAI bridge, then the XDAI chain right now. Speaking of getting all the routers off, I was actually working on this weekend. Getting the routers off of the XDAI chain is going to be expensive in terms of fees because of the mentioned lack of batches in the XDAI bridge. But anyways, the big thing that we're going to try and do there is that we're going to work on partners that will eventually allow you to buy DAI directly on the Althea chain. So that's one thing we're working on. And then another thing that I'm working on that I actually wrote up a plan for in my design notebook just this weekend is to do some time shifting on deposits. For reference here, and it's really sad, there are no good daily graphs of gas prices by hour. And if you look online, they don't exist. I have to make my own. I have to collect the data myself using the routers. But here's the facts. If when I wake up at 6:30, 7 a.m. East Coast time, 3 a.m. West Coast time, gas may be 48 GWay. By the time it is 10 a.m., 11 a.m., and I'm looking forward to eating lunch, gas is 250, 300, 400 GOA. So if we time shift deposits by just a few hours, we can reduce the fees by some odd 60, 70, 80%. So what I'm going to do is I'm going to write some code for the routers that samples the ETH gas price for the last 24 hours, computes an average, and when it finds the daily minima, it just shoots out all of its transactions. So what'll happen is that the user will deposit, and they'll get a nice little message that's like, hey, we see you deposited ETH. It'll be processed, and it'll give an estimate. And if they have absolutely no funds, and then there's going to be some little heuristics logic that's like, oh, their balance is completely empty. They deposited $100. This fee's probably okay for now. Go ahead and send it through. There's a little bit of fuzzy logic there. But for the most part, we're going to try and get the fees to go through this whole process down below $2 or $3, which I think is completely doable. The most expensive part of this entire process is calling Uniswap, because remember, sending to the Peggy bridge is the cheap part. You pay for one ERC20 send. So we may eventually do something with Wire where you buy DAI directly, and then you also buy enough ETH to cover the transaction cost, or you use wrapped DAI to pay the fee. This all depends on how easy it is. So there's lots of avenues to solve this problem, and right now we're just sort of working on all the available ones. The obvious easy one is just time shifting. Time shifting's a big win. It's easy to implement. Doesn't require us to do anything fancy. Then we can get into buying DAI directly from Wire and having some code on our end that uses that DAI to pay the gas. And then eventually we can try and bring someone onto the Althea chain themselves who moves DAI over in bulk and then provides a resale process that way. And then that'll be the ultimate solution that's very cheap.
Hey, Justin, there's a heat map I just pasted over in the Discord that I've been using pretty effectively to knock these transaction fees down from, like some people are paying, $25-30, and then I'm paying $4 or $5, $6 sometimes for the same transaction, just by shifting it as you speak. So this, I don't know if you've seen this before, but
yeah, this one's a little bit better than the others
really
I've seen. Yeah, this
helpful.
is much better. This is much better than the others I've seen. You see, I did a survey of this a few months ago, and I got frustrated, and I wrote my own code to gather it. And it's a good bit higher resolution than this graph too. But this is the best publicly available one I've seen. But yeah, so take a look for reference. Gas prices on last Monday ranged between 420 at 2 p.m. Eastern Time and 66 at 3 a.m. So yeah, time shifting's the obvious way forward. And I'm going to try and get that into the next Althea firmware version. That's what I've worked on a little bit this weekend.
Sorry also has in Ethereum gas fees. Somebody built one, and so if you zoom in, you can track by the hour, but just by holding it over. So I don't know how well that could be used, but if anyone at Cosmos or ICF has access, they should, because Cosmos is all the information's updated. So somebody has access to this information. You could be able to ask to use that information.
Yeah. Sounds good. I'm glad that this information is out there, and clearly everybody's looking for it. I was just surprised at how much trouble it was when I went looking for it, that I got frustrated and went and just did it myself. But these are already much better than the ones I just saw at the top of Google. So clearly SEO for this sort of stuff is just not very good. But anyways, gas fees, big problem for everybody. There's just a lot of optimization to do. Speaking of, I put a lot of gas optimizations into the Peggy orchestrator and relayer over the duration of this testnet. Previously, it would not actually check. How should I put it? Now it actually checks if what you're about to submit is valid and will work, and if somebody else has already submitted it, and does everything it can to not send a junk transaction that's going to get you a fee charged, but not actually do anything on the Peggy bridge. Um, and I also fixed an oversight in the Solidity code where it would actually go through the entire signature verification process before exiting if the nonce was wrong. So if, for example, somebody submits a validator set update and you submit a validator set update at the same time, both of these transactions are in the mempool. One gets executed, yours then gets executed, like let's say a block later. It's going to fail because obviously the nonce is wrong. Your transaction says that the nonce should be 16 and you're updating it to 17, and the other transaction's already updated it to 17. So now it will exit pretty much immediately after doing that one integer comparison, instead of doing all the signature verification, eating your gas, and then throwing. So yes, lots of little improvements like that made their way into testnet 1.
So I just wanted to make mention of the IBC test I did.
Mm-hmm.
When testnet 1 was running, it actually turned out to be pretty easy to do an IBC transfer. The only problem was that the prefix for Peggy tokens is Peggy / something, and that gets rejected loudly by the Cosmos SDK. So I could hack around it by changing what the Peggy chain was using and just running it locally. I could remove that check and run the Peggy chain locally, and then the outbound IBC transfer would work, but the inbound one would not. So it's IBC transfer ICS20 is just really hard coded to using slashes in a certain way.
Yeah, I saw well, first of all, thank you for taking the time to test this out. And I saw an upstream GitHub issue on maybe loosening these restrictions. Is that going to happen by Stargate RC5, or are we maybe going to have to consider changing the Pegi separator so that all of the consumers of the Pegi module running RC5 can use IBC?
Yeah, so Zaki's opinion is just change the separator and don't worry about what IBC is going to do, because there's enough pushback from the Cosmos developers that they don't want to start changing things now.
Mm-hmm.
And
I can agree with that.
Yeah, and specifically it's because there's some reliance on it being like the transfer port / the transfer channel / the denomination.
Mm-hmm.
And once you have that, then if you have a / separated denomination, then you can't do multi-hops anymore, because you just can't tell which part is the channel and which part's the denomination anymore.
Mm-hmm.
Yeah. So Zaki was suggesting just to change it to a dash, so Peggy dash something.
Yeah, I think that'll work just fine. Obviously, it's completely arbitrary, and we don't even really need the dash. We can just do Peggy 0x Ethereum address, and that'll work fine too.
Oh yeah.
But yeah, so we'll make sure to get that done when we merge in slashing and before Peggy Testnet 2, and hopefully we can get some real IBC stuff in Testnet 2, and sort of achieve, because how should I put this? So IBC plus Peggy unlocks real potential for aggregate demand, because the thing with the way the Peggy contract is designed is that the more you do at once on Ethereum, the more money you save. Because if you try and do, so how should I put it? In a Peggy transaction batch, when you're withdrawing 100 transactions from Cosmos to Ethereum, we managed to send 100 transactions in some odd 2 million gas. Now, if you were sending each of those ERC20 transactions individually, they would cost at least 14 million gas. And you ask, well, why is that? And that's because the way gas is computed by Ethereum, there's a base fee for the first time you call it. There's a fee for instructions in the EVM, like jump instructions. And you end up loading the arguments into your registers to call in to the ERC20 contract, and you don't pay the base fee again. You pay a very small fee per argument, per byte in your arguments to the contract call. So the more stuff you can aggregate, the cheaper it is. So the big promise of IBC is that Cosmos can have several chains running Peggy, but each of them with higher volume than if every chain ran Peggy. And like the Cosmos Hub or some other large zone can have a Peggy instance and successfully aggregate transactions to and from Ethereum and dramatically reduce the cost for everyone. Because the more transactions there are to hitch a ride with, the lower your costs are. So IBC is an important use case for Peggy, just sheerly because of aggregation.
Yeah, absolutely.
Justin, next steps for validators?
Yeah, next steps for testnet 1 validators. You can pretty much shut things down now. Unfortunately, further updates to Peggy and stuff will not be compatible with the existing chain. We're going to make a few changes to the contract. We're going to make some changes to, obviously, we're upgrading to RC5, and the current Peggy binary does not have support for chain upgrades, so we can't take testnet 1 into testnet 2. So I'd like to thank everybody for their participation and their time, and especially their patience with this whole testnet sort of running into the holidays. And I look forward to announcing testnet 2 soon.
For testnet 2, Justin, these first kind of couple were, I would say broken nets, right?
Yes.
Very, very early iteration. Does testnet 2 feel like we want to get a few more folks on board and have it, be maybe a little bit more of a larger set? Or is this still going to be kind of another broken net?
I think it could still be kind of another broken net. I mean, so obviously we are iterating. More stuff works every time. And I think that we're starting to reach the point. So testnet 2, like I was saying, had a lot of people come in later on and join the validator set. Whereas in BrokenNet, if you weren't there in that Zoom call, the documentation wasn't there. The software was too finicky. But for testnet 1, more than half of the validator set came in later. So I think that we've sort of got one foot in each world. We should probably try and bring more people in to practice before we do the incentivized testnet. And obviously we want things to break before it does the incentivized testnet. So I think we should push forward with testnet 2 as a sort of higher expectations, serious Peggy testnet that's more, that we encourage people to more publicly participate in.
Cool, sounds fun.
Well, cool. Thank you, everybody, for taking the time to show up and taking the time to validate and keep up with Peggy. If you have any more questions, you can find me in the Peggy channel in the Cosmos Discord and in the Validators channel in the Althea Discord. And just shoot me a message if you have any questions, and I'll be happy to go over them with you. So yeah, guess I'll see you all in 2 weeks, hopefully with some information about slashing testing.
Great. Thanks a lot, man.